Alright guys, let's get started. This is chapter 4, lesson 4, multiplying mixed numbers. As you do this lesson, think about what does it mean to actually multiply into fractions. Okay, there's going to be two goals for this lesson. The first one is to multiply a fraction into a mixed number, and the second one will be to multiply mixed numbers. Okay, now for goal number 1, I just want to remind you what a mixed number is. Okay, the noise you hear is the wind outside. It's pretty windy today. Alright, we have a mixed number. It's a whole number and a fraction. So 1 and 3/4. So it's 1 and 3/4. You're adding them. Okay, keep that in mind. You're adding two things, you're putting two things together. 1 and 3/4. 1 and 3/4. What does it look like? Well, look at the denominator. We're making sets of 4, right? So we have one full set of 4. Right, let me just see if I can shade this in. One full shaded set of 4. I shade that in. And that would be 4 out of 4. 1 out of 4 looks like this. Same thing. We're making a set of 4. But we don't think we only have 3 out of that 4. And keep in mind always, part to whole. Part to whole. That's what a fraction is. Part to whole. Right? Keep that in mind. So the whole would be 4. Right? And we have 1, 2, 3, 4, 5, 6, 7 parts, 7/4. Okay. Now this is an improper fraction. There's nothing wrong with it, but it's not really what a fraction is. A fraction is supposed to represent less than 1. And this is actually more than 1. And there's the proof, 1 and 3/4. So to convert back, you would just divide the numerator by the denominator. You're making sets of 4. How many groups of 4 do you have? And you know what? I'll just go ahead and do the work. You can make one full set of 4 with 3 left over. The remainder becomes the numerator, and the denominator, which is the divisor, again, back and forth. So I want to remind you what that is. Alright, so let's get started with the got it's. The first one is letter A on page 282. Okay, letter A. We have 2/3 times 2.5. Pretty straightforward, right? But here's the thing. What are we actually doing here? We're taking 2/3, right? And we're doing this twice, 2/3 twice, and then we want half of 2/3. So it's like basically you're drawing 2/3 3 times. 2 full sets of 2/3. Well, it sounds funny the way I said it, but imagine 2/3 twice, and then for the 2/3 that you have, that's the third one, half of that. Okay, that's one way to look at it. Yeah. So let's see if we can do this. I'm going to rewrite it just a little bit. 2/3 times 2 and half. Okay. So I want 2/3 twice. Again, ideally all the pieces would be equal, but unless you get a ruler and be real specific, it'll take a while. So I might do that. So 2/3 times 2. Use a different color. Two-thirds twice. Right? But now I want half of that 2/3, right? So let me draw another 2/3 like I said we would do. It'd be say 3. Alright, you're like, wait, what did you just do? Let me show you with an equation. We took this 2, and I said, okay, I'm going to draw it 2 times. So what we just did was 2/3 times 2. 2/3 times 2. Plus 2/3 times half. right? Okay. Let's see if we can do this. Here's my 2/3, which would be the red. And the blue would be the half. All right. Remember what I said, part to whole? Let's look at this. Add 3 pieces. And out of the 3 pieces, I only wanted 2. Okay? And out of the 2 pieces that I did have, or that I do have, I only want half of those pieces. So there's my half. Where they cross is what we really have. Okay? So let's consider this. The 3 pieces we started out with, when we did not mistake, now I'm saying each piece I want it to be 2. 2, 4, 6. So the whole now is 6. But how many pieces do I actually have? 1, 2. 2 sixths. But is that the final answer? No. No, it's not. What about this over here? Again, we're making sets of 3. But how many pieces do we actually have? 1, 2, 3, 4. 4/3. And we're adding all this together. You're like, wait a minute, that doesn't make any sense at all. Right? You can't. You can't add fractions unless they have the same denominator. These pieces are much bigger than these little half pieces here, right? So we need to find a common denominator. Now if you remember, you should already remember this, it's going to be 6, right? Times 2. What does that times 2 mean? It means each of these pieces now becomes 2. 1, 2, 1, 2, 1, 2. 1, 1, 2, 1, 2. So that becomes 1, 2, 3, 4, 5, 6, 7, 8. 8 sixths. That becomes 8 sixths. Right? I'm going to rewrite that. Right? If we're making sets of 6, that's great. The denominator is still going to be 6. We add 2 plus 8. We have 10. We have a mixed number. Or sorry, an improper fraction. We're making sets of 6. You know what? I'm going to do the work over here because I ran out of space. This. 10 sixths. I'm making sets of 6. That the denominator becomes my divisor. My dividend is the numerator. I'm making sets. I have a full set of 10, or I have 10 pieces. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. I'm making sets of 6. I can make one full set of 6. I have 4 left over. It'll be 1 and 4 out of 6 with 4 pieces left. But don't forget to simplify. One and 2/3. Right? And if you think about it, I don't know if this will work if you can see it. It'd be easier if we had do this in the classroom, but we're not. Okay. The one full set, look at this. I have 2, 3, 4, 5, 6, 7, 8. The sizes are the same. If I take these 2 pieces right here, I have enough to fill in this over here. That's one full block with 2/3. Okay? Alright, now, I'm not going to ask you to draw for all of them. That'll take forever. But I do want you to understand the process. Okay? I want you to actually understand what you're doing. Let's review real fast before I move on. 2/3 times 2 1/2. That's 2/3 times 2 1/2. I drew 2/3 twice. 1, 2, 2/3, 2/3. And I drew 2/3 again. But this time I said, hey, I want half of that. Right? And we did the math here. Again, I showed you really equation-wise what it looks like. 2/3 times 2 plus 2/3 times 1/2. We did the math. You can see here that this 2/3, we're still making sets of 3. 1, 2, 3, 1, 2, 3. And we had 4 pieces. Right? Remember this? We can rewind the video if you're not sure where I'm going with this or where I came from. And this, again, 2/3, we want half. We need a set of 6 again, right? And we only have, let's see, out of a set of 6, we have 2 pieces, 2/6, right? 2/6 plus 8/6. Because this, if you put it together, where do I get the 8/6 from? 2/6 plus 4/3, 8/6, right? But that, again, you have to add it to what you had before, plus the 2/6, which was this, and you get 10/6, okay? 1 2/3. Look, it really is kind of hard to understand after the fact. I suggest truly rewind the video, play this as many times, and when we get to class, we'll try and use something real that you can hold in your hand and see this, okay? But let me show you another way without doing all this drawing stuff, okay? I'll make it as easy as possible. Letter B. 3/8 times 3 1/3. All right, without making any kind of drawings, let's just do a little estimating, just see if we can get the answer right. 3/8. All right. Remember the benchmark fractions, 0, half, or 1? 3/8 is pretty close to half. Again, I'm just estimating. You don't have to do this if you don't want to. All right, 3 and then 1/3. We're just making a real quick prediction. All right, 3 stays the way it is, but the 1/3, are we closer to 1, 0, or half? 1/3 is pretty close to 0. So let me rewrite this, see what we can think. It's just a quick prediction, quick estimate, okay? Basically, we're asking what's half of 3. The answer is going to be about 1.5. And this is an estimate, approximate estimate. All right. Now let's do the actual math and see what the answer is. 3/8 times 3 1/3. All right. As you saw, the best thing to do is to change mixed numbers to improper fractions. Okay. 3/8. We're making sets of 3. The denominator is 10. You will not do anything to that denominator. We're making sets of 3. We have 3 full sets of that. That means you have 9 pieces. 3 times 3 plus the 1. The 1 piece is right there. Okay? If you've been paying attention to the other lessons, you'll understand how I got this. Okay? All right. Numerator times numerator, denominator times denominator. 10 times 3 is 30. 8 times 3 is 24. All right. This is an improper fraction. Your answer is going to be more than 1. Now, you have 2 choices. You can simplify now and then change this to a mixed number after you get the simplified fraction. Or you can just divide now and then simplify later. Okay, me, I tend to like taking care of numbers when I can. Simplify when possible. But that's just me. All right, 30 and 24. I add the digits. 3 plus 0 is 3. 2 plus 4 is 6. 3 and 6 are multiples of 3. That means I can use 3 as a common factor. Okay. Now some of you might know you can also use 6, and that's great. If you know that, you're on top of it. But if you didn't know that, now you know why it's 3 at least. 30 divided by 30 is 10. In my head, gonna mix up the answers. 24 divided by 3 is 8. Okay, again, I can simplify here, but I think the number's small enough. I'm just gonna go ahead and divide. I'm making sets of 8. And that would be my divisor. My dividend is 10. Again, a fraction is another way of showing division. How many groups of 8 can I make from 10? Somebody already knew this. You can make 1. And that's pretty much it. So the answer would be 1 and 2/8. But I look again just to make sure of something. Can I simplify this? Yes. They're even numbers. I can divide by 2. 1 and 1/4. And this is the answer. 1 and 1/4 is 1.25. We said the answer would be 1.50, 1.5, That's pretty close. So my estimate was pretty close. That ensures that my answer is reasonable. Okay? So if you want, I can show another drawing for this if you'd like, let me know. But for now, that's all it is. Change mixed numbers to improper fractions and then multiply it like you normally would. If you get an improper fraction, change it to a mixed number. You know how to do this. Okay? And let me go back to this other problem where I made the drawings. Seriously, watch the video again from this point. I know when I try to explain it after the fact, it's kind of hard to see where I got all these numbers. Like, even I got a little confused trying to make sense of what I just did. Because it's like trying to figure out how you made a building after the building's already made. It's kind of hard to see it. You can imagine it, but it would be best just to go back to the beginning and see how they started from step one. Okay? So don't look at the building after it's built. Look at the building before it was built. Look at all the steps I did, all the thinking I had, okay? If you need to watch this 3, 4, 5 times, don't be embarrassed. Do it, okay? Anyways, that's goal 1. Mixed number times a fraction. Okay, now it's time to go over goal number 2, multiplying mixed numbers together. So I want to remind you again how to change a mixed number to an improper fraction. So if we had, let's say, let's pick something up, 1 and 7/8. Okay, I'm not going to draw a picture. Don't get all scared. Think about what we're saying. We're making sets of 8. Denominator stays the same unless you simplify, but we're not simplifying anything yet. Sets of 8. How many full sets of 8 do we have? 1. So 8 times 1 full set plus 7 pieces. All right. BEMNAS. Order of operations. You do multiplication first, right? 8 times 1 is 8. And you add the 7. By the way, I realize I should be using pencil, but since I already started with pen, let's finish it off. 8 plus 7 is 15, and 8. So 1 and 7/8 is the same as 15 over 8. Now, please understand, an improper fraction, there's nothing wrong with it. It just kind of goes against the concept of what a fraction is. A fraction should be less than 1. An improper fraction is more than 1. Okay? So I just want to remind you that. All right. Let's go. Let's see what we have. We have a word problem, letter C. I know for word problems, I'm going to draw a picture. Okay? Just to help me out here. Mr. Wilkins is laying bricks to make a rectangular patio. The area he is covering with bricks is 15.5 feet by 9 3/4 feet. What is the area of the patio? All right. I hope you know what bricks are. I don't want to go into that. But he is making a rectangular patio. So I'm going to kind of draw a big one, a big rectangle. $15.5 by 9 3/4. Okay, so basically we're saying what's the area is its length times width. So area is length times width, right? Okay, now let's make a prediction of what the answer is going to be. Bear with me. Here's the equation. Okay. All right. 15. There's no reason there's no point in estimating that. It's a whole number. 15 and half is half. That just stays the same. 3/4, I'm going to say it's pretty close to 1. Okay? Just for sake of argument. Again, we're just estimating. This is, you know what, I'm putting on the side. We're just estimating. Before I do anything, I just want to make sure I have what the answer is going to be. Okay. 15.5 times 10. Okay. You're like, what is he doing again? In my head, I like the whole numbers first. But you know what? Let's just work with what we have. I don't want you guys getting all confused. What's he doing? So we have 15 and a half times 10. So if you can imagine 15 bricks going this way, right? Times 10 times 10. 10 bricks, 10 rows, or 10 columns, right? It's going to be about 150 bricks plus half of 10, right? Remember how that works? Half of 10 would be 5. So the area would be 150 square feet, or 55 square feet. Again, this is just an estimate. It's not the actual answer. Now I'm going to do the actual math, and you can see what's going on, okay? Okay, with what I showed you earlier, you got to change these mixed numbers to improper fractions. We're making sets of 2. We have 2 full sets. Again, denominator here will be 2. And my cell phone just went off. Ignore that, please. 2 times 15 full sets plus 1 piece times, again, we're making sets of 4 here. The denominator stays the same. 4 sets of 4 times 9 full sets plus 3. 2 times 15 is 30 plus 1. I know I'm taking a while, but I want you to see every little step I'm taking so you see where the answer came. 4 times 9 is 36 plus 3. Oh, wait, don't want to skip steps. Over 4. 31 over 2 times 39 over 4. Can I simplify before I multiply? No, I'm going to have a big old mess. Ugh. Of course I did the denominator first because it's easy. 2 times 4 is 8. Yay. Alright, numerator. You know what? Sometimes you just have to do the work. 9 times 1 is 9. 9 times 3 is 27. And that's done. A place value holder here. I'm done with the ones placed. I go to the tens place now. 3 times 1 is 3. Sorry about that. 3 times 1 is 3. 3 times 3 is 9. Add all that together. 9 plus 0 is 9. 7 plus 3 is 10. 9 plus 2 is 11. Plus 1 is 12. Híjole, that's ugly. But you know what? It's just division. Let's just get over it. Let's get it done. I'm making sets of 8. That's my divisor. My dividend is 1,209. By the way, again, on the quizzes or tests or anything, be specific. For every group of 3, put a comma, because you just finished a family, right? So, just reminding you. Long division, people. I can't make groups of 8 from 1, but I can from 12. I can make one group of 8 from 12. I subtract. Okay, good. I have 4 left over. Keep going. Bring down the 0. I can make 5 groups of 8. It's times tables. 5 times 8. And 40 minus 40 is 0. Bring down the 9. How many groups of 8 can I make from 9? 1. Now, since we're working with fractions, we don't have to worry about adding a decimal point in a 0 and keep going until we get nothing left or round to a certain specified place value. We can leave it here. So let's review. Sets of 8. We have 1,209 to play with. Feet, that is. I can make enough for 151 full sets, right, of square feet with 1 left over, and I'm making sets of 8. Again, the denominator is the divisor. The numerator is the remainder. All right. And that's it.